So at the very top there, got cut off. Context is important. I see some numbers there. What do you think when you look at those numbers?
Weight in miles per gallon.
Oh, so did you read further down already? What if you hadn't read down before that? What would you have thought when you looked at that table? Yes?
I was thinking it's like fractions.
Yeah, maybe it looks like fractions, kind of. Yes?
I would have thought of like f of x as an x. Or
Yeah, maybe it's x's and y's. So it's like a function table or something. And you go, yeah, what do I do with these numbers,
or
right?
like, yeah, like height and distance, or like length.
Yeah, length and width, or who knows. Everyone agree that these numbers by themselves, you could make all kinds of guesses as to what they are, but they don't really mean anything. So context is really saying, I need to know in what context these numbers come from. What are the variables that they represent? Remember your algebra teacher used to always say, state your variables. What is x? Is x your shoe size? Is x your girlfriend's height? What is it? Yes?
So it's basically just giving a meaning.
It's giving a meaning so that you can make sense and make some decisions about it. So if you look at the next table, because Stephen already read down, it gives you a lot more details. Right? The next table down gives you that the numbers are the weights and the highway fuel consumption of cars. And it even tells us that the weights are in pounds and the fuel consumption is in miles per gallon. So somebody interpret some number on that table for me. Pick a number on that table. Tell me what it means.
The miles per gallon, how many miles you get to, I don't understand.
Yeah, but which number? Pick one of the numbers.
Oh, like 31.
Okay, what's the 31 on that table mean?
That means if that car that weighs 315 pounds gets 31 miles a gallon, or that particular car does.
Okay, so did you guys get that?
Yeah.
The car that weighs 3315 gets 31 miles to the gallon. So now we can actually make sense of this table and make some decisions about it. Now we have everything labeled so nicely. So one of the first questions you're going to be asked on your homework is, what questions can be answered here? Now that we know what the table means, what kind of questions could we answer with this table? I don't know what the answers are, just what are the questions? Yes?
I have a question.
Yes?
I mean, like, how are we supposed to answer these? It should be in simplest form. Or how should we answer these ratios?
They aren't ratios. It's a table that tells you a car's weight and its corresponding miles per gallon.
Okay.
And the question I'm asking is, what questions could we answer given this information? Yes, sir.
How far we can go with how much, like, say you're driving, tells you how far you can go.
Okay, so if we knew, we would need more information to talk about how far we can go. Because all we have are the weights and the miles per gallon. So I wouldn't be able to figure out how far.
How, if you had a full gallon.
Oh, on 1 gallon,
If you had
yes.
a full tank, like couldn't
Okay, I like what he's saying. You guys hear what he's saying? He said if you had a full tank, you could figure out how far you could go. What's the problem? What don't we know?
We don't have a full tank.
Yeah, how much is a full tank? If my tank holds 20 gallons and your whole tank holds 30 gallons, now...
for a specific car.
Right, so my question is, what could we answer just with this data that we have? Yes?
We could answer how many miles we can go in 1 gallon of gas.
Okay, so how many miles you can go on 1 gallon of gas? That's actually what they gave us, right? So maybe the last car can go 30 miles on 1 gallon. Yes?
Could this also mean that the heavier the car, the less the miles per gallon, or?
Well, that's a question that we could try to answer. I mean, that's really what I'm trying to get at. What questions could we come up with? So she says, maybe we should look to see, do the heavier cars get worse mileage?
But then if you look at this one that's 4,100 and 3,650 are the same.
Right, but so whether or not what the answer is, I don't really care about yet. So we can argue about whether it's a yes or no answer, but the question is, what questions could we do? So we could check to see if there's a relationship between the weight of the car and the mileage.
Which there usually is, because the heavier the car, the less it's going to get.
Right, which we
on
might
average-
think is
on
true,
average.
but we could analyze that. Yes?
How much gallons we would need to travel?
How many gallons? So if we knew how far we wanted to travel, we could figure out how many gallons of gas to buy. We could do that if we remember a little bit of our algebra. We dust off the cobwebs in there. Yes?
The problem with some of this is, like, the reason it might be the same is because the engine, like what kind of fuel it needs.
Right.
There's
So
other factors.
at this point, we're not trying to answer if it is or isn't a relationship. We're just talking about what questions we could answer. the thing that ties our hands with statistics is we can look at questions, we can come up with relationships, but we can't really say why. I mean, I can tell you that people who are taller tend to have bigger feet. It's true, there's a relationship between height and shoe size. I can't really tell you that your big feet caused you to be tall. It doesn't even make sense to say that, right? Or your height caused, I mean, there's a relationship, so we can't really talk about the why all the time. Yes?
Okay, so could a good question to ask this be, like, I have a question to ask this, actually. And how about, is it better to drive a lighter car or a heavier
I
car?
think that's the same question again, really. Do the lighter cars or heavier cars, does it make a difference? So that's one of the questions. In terms of mileage, that's one of the questions we can answer. We can also answer simple ones, like what's the average weight of a car? What's the average mileage? Something like that, yes.
Which one is the most, uses, which one is the most efficient mileage? Miles per gallon?
Yeah, so we could probably spend all day coming up with more questions, but we'd be bored. So the idea, though, is when you have data that's relevant, you have the details and the context from which it comes from, you want to be able to say what kind of questions could I answer, what would be relevant, what might be interesting. You guys are going to be doing projects pretty soon, and you're going to collect some data, and you're going to have all these numbers, but you want to know what questions you could answer with that data. Just because you know all these numbers doesn't tell us anything unless we can decide how to make a conclusion based on it. So even before we get the data like this table, where we get it and how we get it is one of the most important things, in that we don't want any bias in our sample. Our sample is the name for the group of numbers or people that we use to collect our data. So if I'm trying to find out what the average American thinks of Donald Trump, we'll talk politics on day one, here we go. If I want to know what the average American thinks of Donald Trump, I'm not necessarily going to just take all of you guys and find out, give them a number on 1 to 10. I'll take you guys and average that number. Why would that not be the best? Yes, sir.
It's just one specific area, it's not the whole entire region of the country.
Yeah, I'm taking college students who are eligible for statistics who live in the Bay Area of California. I'm not so sure that represents the whole United States. We could argue about whether or not it does, but it's not it's not the best sample to really represent my whole population I'm talking about, right? So there's lots of ways that you could have some bias in your sample. You could have people volunteer to be in my survey. So let's say I went out to the whole U.S. and said, hey, let me know if you want to be in my survey. I want to know what you think about Donald Trump. That's an example of the first bullet here. 1 second, please. Called voluntary response sample, where people volunteer to respond. Who do you think is going to volunteer to my question of what do you think of Donald Trump?
Either people who like him or people who don't like him.
People who really like him or people who really don't like him, or people who feel strongly one way or the other? If you're just, I don't really care one way or the other, if you're in the middle, are you really going to bother to respond to my question? You might, but why, right? So the problem with voluntary response is that you get extreme results and really not what's typical. Yes, you had a question.
I was going to say, you could say that in this classroom, this is what in this classroom, these are the statistics from what.
Yeah, so if I wanted to find out information on what statistics students enrolled in my classes think, then I could certainly ask you guys for that information.
So you have to be more specific in this class?
You need to be clear on what your population is, meaning the large group that you want information about, and making sure that your sample comes from that large group and represents them.
Yeah. Okay.
So if it was all United States citizens, you guys are sorry, not the most representative sample of the entire United States. You have too many things in common and it's too limited. But if it was my LMC math students, you guys are a pretty good sample. So that's voluntary response sample, also called self-selected. Is that clear what that means? Then there's reported versus measured results. I'm going to ask you all what your high school GPA was. I don't really want you to answer the question. I'm just saying I'm going to ask the question. What was your GPA when you graduated from high school? And you're all going to tell me what it was. Everyone's going to give me an answer. And I'm going to find out that the average was, I don't know, 3.1. Yes?
3.7.
I don't really want it. I'm going to say I could ask you that, if I did, but thank you. So I could ask everybody and average it, but I'm not going to. And the average might be 3.1. But then, being a statistician, I'm going to go out now and I'm going to go collect all your transcripts. because I like to look at the data. And I'm going to take all those numbers and I'm going to find the average. And it's not 3.1, it's really 2.9, that average. Why is it different? Yes?
Because it's like, because you get different GPAs for different semesters and years.
Well, I don't think so. I mean, your GPA when you graduate is your GPA when you graduate.
It doesn't specifically state what everyone's GPA is.
Well, first I'm going to ask everyone their GPA, and then I'm going to get their GPA off their transcript. So there's a way to do that. Yes?
There's a difference between what people tell you and what's actually the truth.
Yeah, why is there a difference between what people tell me and what's actually true? Yeah, some people might be embarrassed by their GPA. Yes?
I feel like a lot of times GPAs are rounded up versus like the actual full. If you actually look at your GPA, it's like point and then 4 numbers, not just a 3.2 or a
Right.
2.9. It's usually rounded up.
Yeah, so maybe it's rounded so you don't get the actual thing. I saw another hand. Yeah?
I was just gonna say that it's basically like outside factors influencing an individual to like, if like say there's like pressure on them and they're like, oh man, I had like a 2.1, I'm gonna say I had like a 2.9 versus if you just measure it, you're finding what it actually is on the transcript and you're actually taking the averages.
Exactly. I mean, if I had a 2.1 high school GPA and someone put me on the spot right now, I'm like, maybe it was a 3.1. I mean, a little bit of embarrassment. There's another one too. Yes?
I forgot what I was gonna say about, well, could it be that the cumulative GPA is different from the current GPA? Could that be a reason?
It could, but I'm looking for, look at the directions here, the terminology, the difference between reported versus measured. So I'm still looking at the overall GPA at the end. Some people report, some people measure. Yes, ma'am?
Somebody could not correctly remember their GPA.
Yeah, if you asked me my high school GPA when I graduated, I have no clue what it was. I could guess, but I doubt it would be accurate. It might be a good guess. Well, so you might not remember if you're reporting something, you might be embarrassed, you might change it for whatever reason, but I would definitely probably get different numbers. Which one do you think is better to figure out what the average GPA is?
Measured.
Measured. So in real life, if you could measure everything, it's going to be much more useful than asking for people to report it, just for the reasons of accuracy. Yes?
And also, couldn't it hurt someone's feelings? Like, for example, if you had like a 2.8 GPA and the average was 3.1, and then that couldn't that hurt your feelings if it was like if you found out you were below the average?
Right, that's kind of what we were talking about. People might change their number to not be embarrassed. So that's one thing that really biases your sample is if you do get reported information versus measured. A lot of these are problems when you're collecting a sample. They're not necessarily problems that you can solve. Sometimes we have to make these errors just because getting their data is too difficult otherwise, but they're things to watch out for. The next one is small samples. Those cars we were talking about. How many cars were we talking about up there?
5.
5. Did those 5 cars enough information to really tell us about all cars?
No.
It's just too small. I mean, you might just have one car that's really extremely different, where maybe if we had 20 cars, it would be a little more useful. Or if we had 50 cars. So if you have a too small of a sample, it's not going to be enough information to really give you the conclusion you're looking for, or not even the conclusion you want to find. What do you think if I wanted to know the average GPA of LMC students? I think there's about 10,000 LMC students, roughly, probably a little bit more. How many people would I have to sample to get a fairly accurate idea of what it is for everybody? So I don't want to average all 10,000 numbers. That takes too long. How big of a sample is big enough, you think, to be accurate out of like 10,000 students? Yes, sir.
Maybe 100.
Maybe 100, he says. Anybody else have an opinion on how many need to be in a sample?
Say 1,000.
Maybe 1,000?
10%.
That's 10%, yeah.
3%, maybe 2,000, 20%.
Maybe 20%? Anybody have another idea?
Say like 40.
40?
Students.
40% or 40 students? I
Like
didn't hear.
40%.
40% of the students? Well, clearly the more we get, the more accurate our results would be, right? It turns out that as long as you have 30 or more, it really represents the whole population. Whether I have 10,000 students or 100,000 students, 30 or more is close enough to the actual result. Now, it's not going to be precise, it's not going to be perfect, but it's close enough to really give you a statistically accurate idea of what it is for your whole population. Now, there's some little error and wiggle room. We're going to talk about that later this semester. But a large sample is something that's 30 or more, and a small sample is less than 30. So when you talk about small samples, it really has no reference to how big your population is.
So it's just less than.
Less than 30, regardless of whether you're looking at 10,000 or 100,000 or the whole United States. If I could randomly get 30 people in the United States to talk to me about Donald Trump, I would probably get pretty accurate results to represent the whole country for that too, even if it's only 30 of them. Clearly, the more you get, the more accurate, but it's pretty amazing that you 30, like out of all of those. Crazy. We'll talk about that more this semester. So these are all the things we're watching out for. We want to watch out for voluntary response, reported versus measured, small samples. Then there's loaded questions. We're creating these surveys. And I'm going to survey, how should I survey people on what topic today? I'm going to survey on
What kind of food they eat?
what kind of food you eat. I like it. And so I'm going to write a question in my survey that says, do you know that your chances of getting diabetes are much higher if you have a lot of carbs and sugar in your diet? How much carbs and sugar do you think you eat? I don't want the answer. What did I just do in the way that I worded that, though?
People are likely to lower.
Yeah, he thinks they're going to lower their amount. Why? What did I do when I asked it? Yes.
Because they might be embarrassed to reveal that they eat a high number because they don't want to sound diabetic or unhealthy.
Yeah, and I don't know if it's necessarily just embarrassing, but the way I phrased it, I kind of gave some pre-information telling you how bad it was for you, which makes you realize, oh, I should cut back. Even if I didn't plan on cutting back before today, now I think maybe I'm going to say I am, or maybe I really am. But because I loaded it with that extra information, it might affect their results. Or if I had just asked you, hey, how many carbs and sugars do you eat in a day, if you actually knew, measured, we could measure it, right? It might be different if I hadn't given you that information. Similar to that is order of questions. I might ask you all, who wants to go jump in the ocean in San Francisco tomorrow? And some of you might be willing to do it, I don't know, it's cold, I agree. But I might ask that question. And then I might ask a follow-up question. These are all hypothetical, mind you. Did you hear about the shark attack in San Francisco yesterday? What would happen if I swapped the order of those two questions?
Your results.
Yeah, my results are probably going to change. I don't think somebody might still be crazy enough to want to jump in the ocean. But by changing the order of my questions on my survey, it's going to completely affect my results. Right? I mean, if you didn't know about the shark attack, you might have been crazy enough to jump in the cold ocean. But the cold shark-infested ocean is now a little different. Right? So when you write surveys, you really want to think about, what are the questions I want answered, and will this question affect the answer on the next question, and so forth. It's a lot harder than you think. You've been filling surveys out your whole life, but it's a lot harder than you think. So in my mind, loaded questions and order of questions are directly tied, where one gives you some information that affects the next part. And then there's non-response, where people just refuse to answer. That happens all the time. Someone sends you a survey and you don't answer it. How many email surveys do we get? Well, I'm not answering that. Or if I asked you your high school GPA, you might have said, I don't want to tell you that, Jill. Sorry. Or maybe you just refused. I don't remember. I'm not going to say anything for whatever reason. If I left out everybody who doesn't remember or is embarrassed, and then I just average those people who are willing to participate, it now doesn't represent everybody anymore. Sometimes you get what's called non-response. It happens all the time. You think people get every survey back? I actually just responded to a survey the other day. And you know how when you fill out a survey, they ask you, I don't know, 5, 6, 10 questions about their product or whatever, and then they say, do you have anything else you want to say? And so I wrote in there, yes, please stop sending so many reminders to fill out your survey. I only fill out the survey to tell you that you asked too often to fill out your survey. I wrote it in there. It was driving me crazy. But not everyone sends it back, so of course they're going to hound people to get more answers because they want their feedback. What kind of feedback are they getting looking at this list by hounding people to return their survey.
Pretty much,
Yes.
I'd say pretty negative feedback because people don't even want to do their survey, so.
Oh, but if they're getting feedback back, according to this list, yes.
It's voluntary.
It's a voluntary response sample. The only people responding to their survey are the ones who feel strongly one way or the other, or people like me who are irritated enough with them to respond to their survey to tell them I'm irritated. But it affects their results. And then there's the self-interest study. A self-interest study is one where the person or the company has some stake in the outcome of your statistical research. So maybe I am the person who manufactures these fabulous water bottles. And I want you to know that I did this statistical analysis and I collected all the results, and people prefer this type of water bottle over anything else. And my stats show that. Now I think you should all go out and buy one. It's the best one, because my company, of course. All of that might be true. It might really be the best one ever after all the research, but what's the problem?
Biased.
It's biased because
You're the company.
I own the company. So even if it's a true statement, I'm going to benefit from you all running out and buying this fabulous water bottle now. So we have to be really careful because I have some interest in the outcome. You will see companies who hire outside agencies to do their testing and to do their surveys so that they won't be doing their own research proving that they're the greatest thing ever, right? I mean, that's the whole idea, is we want to make sure it's not biased at all. So if there's any interest in the company or the person's side, it's not the best kind of sample to get. Yes, sir?
Have you ever heard of What the Hell?
No, what is it?
It's like a show on Netflix where they pretty much, they like kind of make red meat or just meat in general sound like it contributes to like diabetes with just like the saturated fat content. And pretty much they try to push like veganism. And then like, I have like all my coworkers, they're like, oh, I'm gonna go vegetarian now. And of course, if you put it on Netflix, it's gonna appeal, like, the younger audience is gonna, like, everyone's gonna see it, and everyone's gonna talk about it. And so I freaking, like, I actually, like, watched it, and then I actually found out, like, a week ago, some doctor, like, debunked everything they said on What the Hell. So people are just like, oh yeah, I'm gonna change my lifestyle, just, like, because of this kind of facts they try to push.
And so who knows who's funding that show, right? So
Oh, yeah.
maybe the people who are going to benefit are
Yeah,
going to...
vegans, right?
Yeah, some vegan, I don't know, vegan company or whatever. That's the same kind of idea, you're right. So it's amazing how much we all get manipulated without even knowing that we do it. And the self-interest is hard, because if I do manufacture these water bottles, I really want to know how popular they are. I mean, that's my business, right? How am I going to retire if I don't sell any more water bottles? So I want to know, so I want to get the feedback, but I don't want to do it all myself because then I can't really use my information because you can't really trust me. So it's tricky. One of the ones I always think about is, you know, if you ever watch the Academy Awards or the Emmys, they always have this Price Waterhouse group who does all the tallying of the votes and they bring out the official envelopes. That is a separate entity that goes and counts and gets all the votes so that no one claims and says, hey, there was some bias. You guys all got together and picked this actor over that actor. There's no way there could be any bias in there. So they actually hire these outside companies so there's no self-interest. Last one on that page 2 there, percentages. People will use percentages to manipulate you by not being clear or maybe even saying things that don't make any sense. I might say that I polled some of my students who took my last test, and 95% of them said it was easy. It's a true statement. True statement. I polled some students. 95% of them said my tests were easy. You guys are all hoping that they're right. What I didn't tell you is it was 95% of the people who got A's said it was easy. Right? So I'm giving you a percentage, but I'm not telling you a percentage of what group. Right? Percentage of what? You always want to know when people talk about percents, percent of what? Because it makes a difference. Percent of all my students, percent of the ones who got A's. What if I had asked only F students? Do you think that would have been 95% said it was easy? I doubt it. Yes.
It's kind of like those, when you see like all that like Neutrogena skin ID stuff on like the commercials, like oh, like 90% of like users or something.
Mm-hmm.
And then underneath this results vary.
Yeah. something like
Yeah.
that.
And these people were paid to participate. I always, my husband goes crazy because I always pause my DVR and read the fine print under those to point those
Oh
things
yeah, I've
out.
done that too.
I'm like, look at what it says. It's a statistician. I mean, you guys are statisticians too, you just didn't know it. Another one is people talk about increasing or reducing things by percentages. Like I might say that now that we found out how fabulous my water bottles are here, I've increased my sales by 300%. What does that mean? If I've increased the amount of sales by 300%.
What were your sales before?
I don't know, maybe I sold 100 last year.
Well, then you increased it by 300, so you sold 300.
300 more, because I increased
Yeah,
it by
you
300.
said
So
before.
300% means that it was 3 times what it was before, got added on, right? Every 100% is the whole thing over again. So if you increase it by 100%, I take all of it plus another. So you could increase it by 100%.
That's just doubling your profit.
Right. But what if I was trying to reduce something, like I have a new toothpaste that's supposed to reduce plaque, and I find that it reduces plaque by 300%. Because reduces the plaque on your teeth by 300%. What's the problem with that? Yes.
It doesn't mathematically make sense.
It doesn't mathematically make
Because you
sense.
can only up to 100.
Right, I can only reduce by 100%. If I reduce 100% of my plaque, how much is gone? All of it. So how can you reduce any more than 100%, right? Impossible.
That's not possible because 300 is not all that 100 is.
Exactly, but you can increase by that, but you can't decrease, because once it's all gone, it's
Well-
gone. Yes, sir, you have a question?
Oh, I was just gonna say, they probably just do to get people excited.
Yeah, well, it's amazing what they do in advertising. We're so all manipulated, even though I know it's still, I get caught by it. Did I see another hand?
Well, when you say and it goes up 300%, you're just saying it's multiplied by 3. There's no way of looking at it.
Mm-hmm. Exactly. Okay, so let's turn over to page 3. I'm going to say something loud and clear, and I'm going to say it again. It's going to show up on your lab assignment. Statistics will show you relationships, but it will never show cause and effect. Just like I talked about height and shoe size earlier, there's a relationship there, but it doesn't mean that one causes the other. There might be a cause and effect relationship between something else. For example, the more you work, the more you get paid, usually is true. The more hours, the more you get paid. That's a cause and effect. But statistics doesn't find cause and effect, just finds a relationship. If you see that word cause, this causes that in statistics, the answer is no, there's something wrong here. We are never showing cause and effect, we're just showing relationship. The cause and effect comes from somewhere else, and we can just do more research to come up with these conclusions. So this top part of the page talks about what other conclusions you could come up with besides the certain cause and effect examples here. So if you look at the first one, a study shows that in a certain county, more speeding tickets were issued to minorities than to whites. One conclusion was that in that county, minorities speed more than whites. Yes.
I have another conclusion for that actually.
Okay, great.
That maybe that minorities were charged more for the same level of speeding than whites are.
Right, so maybe there's some profiling going on and they're giving more tickets to minorities? That's one possible conclusion, yes?
There could be more minorities living in that county than whites.
Yeah, maybe that county has more minorities to begin with, so you would expect more of everything. More houses, more speeding tickets, more jobs, whatever. I mean, that would make sense. Anything else? Other conclusions?
More minorities might have cars than other people.
Yeah, maybe the minorities have cars more. I mean, we could come up all day with alternate conclusions. None of that is statistics. Statistics is just showing the numbers and the relationships. The why and the whatever is for another group. A lot of people think stats prove something. We don't ever prove anything. We just find relationships, really. The second one's another one. I like this one. So they did a study and they found that college graduates tend to live longer than those who don't graduate from college. So one researcher concludes that studying causes people to live longer, which means you're all doing great being in my class because I'll expect you to study a lot. So you're going to live really long lives. What are some other conclusions? Yes?
that they got a job that helps them pay their insurance.
Okay, so because they graduated from college, they got a better job, so they can afford insurance. So they're gonna probably live longer because they're healthier from that.
And maybe if they're studying more, they're eating less junk food because they don't have time to eat all that junk food,
Actually, I
which
would say
may make
the
them live
opposite.
longer.
I think, so she says maybe they're eating less junk food because they're studying, and I agree with you. I was always the opposite. I ate too much junk food when I studied, but it could be. Again, we don't know the answer, right?
Yeah.
What's another conclusion? Yes?
Lifestyle, and if you're living, like, say you don't ever get a job and you're living on this, like on the streets and all that, sometimes that makes people feel like suicidal or like something like that, and they just like the stress just gets to them.
So that might be a little extreme, but we could say that people who are college graduates tend to have a little bit healthier lifestyles, maybe
Well,
because they're more educated.
Yeah, I'm saying,
That's what I was gonna say.
Sorry, I stole your answer. They're more educated about how to be healthier, yes.
They can work one job instead of 3.
Yeah, one job instead of 3, that would be nice, wouldn't it? So we could, again, come up all day with alternate conclusions, but all the stats show us is that this is what is happening. And the why just requires more research and more studies. Be careful, there's gonna be homework problems on your lab assignment online that ask you what's wrong with this. Be careful when anything talks about cause and effect. It's gonna show up. Okay, the last little bit here at the bottom of page 3 is a quick review of percentages. You all met the prerequisite to get in this class, but doesn't mean that you remember everything you needed to get into this class. And percentages are going to come and go and be thrown around like you know them like the back of your hand all semester long. So we're going to do a quick review right now. And I'm going to go through number 3 with you, and then we're going to see if you can handle number 4 on your own after I do number 3. Some of you already know how to do it, and that's great. So when you look at 3A, AOL did a survey on their website and asked how much stock do you put in long-range weather forecasts. And 38,410 people chose to respond. Write that number down. And in 3A, 5% answered a lot. How many actual responses were there that answered a lot?
1,920.5.
How did you get that?
I multiplied it by 0.05.
What is the it?
By the percentage.
Okay, so she took 0.05 and multiplied it by 38,410. Let's just pause for a second there. Why do we multiply? Do we know why? We just do?
When you multiply it, because a percentage is not a whole number technically, it's the 0.05. So you would multiply, which reduces it.
So the multiplication reduces it down. One of the tricks I like to remember is that in math, whenever you see the word of, it means multiply. So if you want 5% of something, that's 5% times that. If you want half of something, you take half times that number. That's one little hint here. What else did we do besides multiply? Something else happened with what I wrote down there. Yes?
You turn a percentage into a decimal.
All right, turn the percent into a decimal. It was 5%, but we wrote down 0.05. Well, where did that come from? Out of 100? So 5% really means 5 out of 100. So you could divide that, and it would come out to be 0.05. What's the shortcut to go from here to here?
Move the decimals.
Move the decimal over 2 places?
Yeah.
So any of that, hopefully you remember one or more of those techniques. So that's where the 0.05 came from. We multiply it by 38,410. What do we get?
1920.5.
1920.5.
So there's a half a person floating around somewhere.
Yeah, he's worried about a half a person floating around there somewhere.
Yeah.
This is the exact calculation though. You'll see a problem like this on the lab and on the online homework, I believe, that says find the exact value. This is the exact value of this percentage. And then the follow-up question is, could this be the answer? No. The answer is no, because the question was how many people answered a lot. So what do?
You can round it.
I round it. And we round it to the nearest whole number because we're talking about people. So we round it because that's a 5 or more, it rounds up to 1921. So 1,921 people said a lot in this survey. Kind of remember a little bit percentages? You okay there? About part B. Part B is a different question. We have 18,053 who said very little or none, and we want to know what percent said very little or none. Yes, ma'am.
About 47%.
Okay, I don't know how you got that though. Yes.
Well, you take 1853 and then you divide that by 38,410.
So we take the 18,053, dividing it by the 38,410. How do I know which number goes where?
So 38,000 is the whole.
Who said that? I heard the voice. Go ahead.
Because this is 38,000 the whole.
This is the whole, this is the entire group. The large group, the whole shebang always goes on the bottom. And this is just part of it. So this is some part out of the whole. And so we divide that. If you need to use your calculator as a phone today, I'm okay with it today only. When you divide that, I want to know exactly what you get without rounding.
0.4700078,105.
How many zeros?
3.
7, 8,
105.
105. And depending on your calculator, you might even have more digits after that. Some calculators can show more. We agree with her calculation? Yeah?
Are we allowed to to round that?
So that's a good question. On my tests and on the online homework, it will always ask you to round to a certain place. So for example, this question might have said, what percent was that, and round it to 2 decimal places. So the first thing we would do is we would turn it into a percent first, and then we would round it. So to turn it into a percent, I'm going to take the shortcut we just talked about. I'm going to move the decimal over 2 places. So if I did that, this is now a percent. And maybe I'll say round to 3 decimal places. When you're on my stat lab doing your homework, there's always little blue words underneath the box that tells you where it wants you to round. When I say 3 decimal places, it means 3 places after the decimal, which is this place right here. How do I round to there? Take the number after, and then decide whether to make this go up by 1 or just leave it alone. Since this is a 5 or bigger, and this one goes up by 1, so my answer would be 47.001%.
Okay.
You will always be told where to round. And if you're not told, that means I don't care. Round it where you like. As long as you round it correctly, I'll take it. Okay, try number 4 without me. Can you get it? Pull that door shut real quick. I'll get into number 4. So if your whole grade depends on your answer to this question, who gets an A? Anybody think they got an A? I got 1 A, 2, 3. Only 3 people think they got this one right? 4? 5? We're going slowly. What's the answer if I don't make your whole grade depend on it? In case you're wrong. 312.32?
I said about 312.
About 312 adults?
Yeah,
Yeah. Why do we have to make it 312?
because we need an exact number.
Has to be an exact number of adults, right?
Yeah, because there's no such thing as like a half a person or a quarter of a person or something like that.
And we didn't round this one up.
Actually, do it. It's
What was it before we rounded 312.3?
32.
Right, so we rounded, just left it where the way it was? Okay, so the next couple pages on here, starting with page 4, are your 1.1 lab assignment. The quiz on Wednesday is going to be 1 or more exact problems off of this lab. The rest of these pages here. You're going to be here on time. You're gonna copy down whatever you did for this lab assignment right onto my little quiz paper that I will hand you. I recommend going to the lab between now and then and completing it and asking for help if you need it. But now you know exactly which questions will be on your quiz on Wednesday. Questions? You now know how to do all of those 5 things? If you have questions, let me know. I will see you on Wednesday, if I don't see you before then. Thank you.
You wanna know something?